Hi, my name is Wang Shen. I'm now doing the homework question 2 of homework 11, probability and stochastic processes. Let's see question 2. It is suggested that the following function v, a, b, c, three functions may represent an autocorrelation function of a WSS stochastic processes by setting v equals to tau, or spectral density function by setting v equals to omega both, which function fv may represent either or each. Explain your answers. First of all, let's see question A. First of all, we all know that if r tau is an autocorrelation function of a real WSS stochastic processes xt, then the r tau should be even, and also the r tau should less or equal than r0, and also its Fourier transformation is also non-negative, and if S omega is a power spectral of WS process xt, and the S omega is non-negative. So by the definition, let's see question A. The first function is fv equals to e to the power of minus absolute value of v. We all know that this function is even because we have this is absolute value of v, and also the value of e to the power of minus v, absolute value of v, is less than the value of e to the power of 0, and also we know the Fourier transformation of this function. The Fourier transformation is, which is non-negative. So we meet the two conditions that r tau is less than r0, and the Fourier transformation is non-negative. So we can say that fv can represent an autocorrelation function. And also let's see also because e to the power of minus absolute value of omega is also greater or equal than 0, so it may represent a power spectrum. So this is A function. Let's see the B function. B function is sine v to the power of 2 over v to the power of 2. We know that this function is even, and we can say that this function, when v is to the limit of 0, this function to the limit of 1. So this function is less or equal than the value of 0, and we also can draw the Fourier transformation of this function, which is this. So And actually we can say that this function is non-negative, and also the greatest number of this function is when this function goes to 0. So it can represent an autocorrelation function, and it also can represent a power spectrum, because we can see the picture in the frequency domain. This is also greater than 0. So let's see question C. Fv equal to 1 when v alpha. We can write the Fourier transformation of this Fv, which is 2 sine alpha omega over omega, because this function is not non-negative, so we cannot write this function cannot represent an autocorrelation function. And we also can say that because the f omega of this function, because this is always non-negative, so it can represent the s omega. It can represent the power spectrum. And this is question 2.